slides very clearly. As you all know that we are on lesson 5.4, exponential functions integration, and today is the last lesson about the integration. So far we have learned how to evaluate the integrals using FTC, how to apply the rules of integration in the real life applications also. So by the end of this lesson, you are going to study how to evaluate the indefinite integrals, applying exponential rules of integration as well as the logarithmic rules and the basic rules of integration. We will also analyze and solve the problems regarding the real life application. So the first question, before we start, how to analyze the question and then how do we apply the rules of integration? You guys both know, okay, you guys know that we have two different kinds of methods which we have studied. One, we solve by applying the direct method. It means we just apply the basic rules of integration, the power rule and the constant rule. And then we apply them and then we solve. And in the other method, we apply the U substitution method. So first of all, can anyone answer or show me that when do we apply the basic rules of integration or the direct method? Anybody can help me in sorting out how do we apply the basic rules of integration or when do we apply the direct method by showing us the examples. Omnia, I guess you or Rivka?
I can. Yeah, I can.
Omnia, you can?
Yeah.
Okay, so let's start. So you can share the screen because you have the ability to share the screen with us.
Yeah, okay. Just a second.
Sure. Take your time.
Miss, can I send it to you and you share it? Because there's something in my phone that doesn't allow me to share it.
This is the same thing which you sent me yesterday?
Yeah.
Yeah? Or something changed?
I changed some stuff and all, but like, here. I'm gonna send it to you on WhatsApp.
Okay, this is Omnia?
Yeah.
Okay, Omnia, 1 minute. Let me check, okay? Okay, so we are sharing Omnia's presentation which she sent us, okay? So Omnia, is this one? This is the one?
Yeah.
Okay, Omnia, so can you see the slide, girls?
Yes, miss.
Yes, we can see.
Yes,
Okay.
miss.
Yes.
Okay, Omnia, carry on.
Okay, so here we're gonna learn how to analyze the questions and then how to apply the rules of integration. Okay, here we're asking why direct method. In the first equation, we're asking why do we use direct method? It's because there's only one equation in here, okay? So the question is 3x to the power of 4 minus 5x to the power of 2 plus x dx. So how do we solve this? First of all, we see to each and every number, and then we divide each and every number. We don't solve them together, we just divide them, and then we're gonna solve each and every one, and then we put it in an equation. So 3x to the power of 4, we see the antiderivative of it using power rule. So it becomes 3 over 5 x to the power of 5 to the power of 5 because we add 5 and then we divide it by 5.
Okay.
Yeah, we add 1 to the power. And then negative 5x to the power of 2 becomes negative 5 over 3 x to the power of 3. And plus x becomes plus x to the power of 2 over 2 plus 3. That's it.
Okay, can you
And
just
then,
tell me why do we write plus C?
it's because
And
instead of the x, dx,
no,
sorry.
why don't we apply here plus C? Which kind of integral it is? Definite or indefinite?
Indefinite.
Very good. So whenever you have the indefinite integrals, it means, what does it mean if you have indefinite integral?
We add c, dc.
Okay.
Yeah.
Why?
Yeah, because that's
Yes.
indefinite.
Yes, indefinite. So why we write the plus C?
Miss, because it doesn't have an end and it's constant.
Yeah, constant
Exactly,
too. We
because
use
it
it.
doesn't have the boundaries. Exactly. Very nice.
Yeah,
Okay.
here, if
So,
k is any real number, then indefinite integrals of k with respect of x is here, the equation.
okay. So as Omni explained us that whenever we have the direct equations, we always apply uh, turn off the mics, girls, please. Okay, we directly apply the sum and difference rule, and one by one we take the antiderivative of each and every term. So which means that whenever any polynomial equation is given, whether it is written on the numerator or if any number is written in the denominator or any number is written in the square root or the cubic root, we always apply the basic rules of integration. Okay,
Yeah.
what about these things? Omi?
Okay, so first of all, there's the second question. First of all, we integrate using power rule. So here we find the antiderivative of the first, which is 2x power 4, because we added 1 to the power and we
No,
decided
Omnia,
divide.
Omnia,
Yes,
are
yes.
the screen, is the screen in front of you? I skipped those questions. I went
Oh,
directly
okay,
on the
okay.
second.
Okay, sure.
Hmm.
Here. Okay, the next question is very easy. We just find the antiderivative for a to the power of x, which is a to the power of x plus c. And that's it.
Okay. The
And
other
then,
one?
and the next one, we just find the antiderivative of 1 over x, lastly, which is ln x plus c.
Okay, what is the name of this rule? E to the power x?
What?
What is the name of this rule?
Wait, exponential?
Okay, very good. And what is the name of this rule?
Which one? Wait, I
The
can't see it.
second one. The second one, where you said 1 over x equals to ln x.
I'm not really sure. I forgot about it, I think.
Okay, ln means what? Very good, logarithmic rule.
Logarithmic sum. Yes.
Logarithmic. Okay. So what is important in that exponential function has the x which has exactly one power.
Yeah.
Okay, and similarly here x is in the denominator and x has only one power. So these are the important rules when we apply the exponential and the logarithmic rule. Very nice. Okay, thank you very much. Any question regarding the direct method, girls?
No, miss.
No.
No? Okay, so let's go. Okay, so my next question, girls, is 1 minute, give me a second. Okay, my next question is, when do we apply the U substitution method of integration? When do we apply the U substitution method of integration? Yes, Ravan.
Miss, we apply it when we have two functions, and specifically when we have a complex function. So we
Okay, can you
function
show
first
us
and then
some
make
work?
the u.
Okay, can you show us some work?
Miss, you want me to share my screen?
Yes, exactly. So that we can understand that which kind of examples we can put in the substitution method. Okay.
Okay, can you see
So go to slide. Yes, we can see. Go to the slideshow.
Okay, so basically I'm going to use the U substitution method. So first, like we have some guidelines to apply it.
Okay.
The first thing we're going to do is to recognize, we have to first recognize inner and outer functions. And after doing that, we're going to recognize the derivative of the inner function itself. After recognizing the derivative of the inner function, we need to analyze and see if the derivative is present. If it's present, then we're supposed to apply and like take antiderivative of outer function, and we're going to have our final answer. But if our derivative is not present, then we're going to have to find the missing constant and then take antiderivative of the outer function. So this is basically what you do to apply the U substitution method.
Okay. Can you explain by giving examples, huh?
Yes, yes. We have 3 rules. We have power rule, logarithmic rule, and exponential rule. We'll first like talk about u to the power of n plus 1 over n plus 1. So I'm going to show you some examples. So for example, I have 5x squared plus 1, and then this whole function is to the power, and then we have 10x. So first, let's find the more complex function, which is the one with the power of, like, identify our u, which is the inner function, which is 5x squared plus 1, and we'll get the derivative of this, which is derivative is present, so all we're going to have to do is just do the power rule, which is to add 1 to the power and then divide it by the same number.
Okay.
Over here, so it's going to be 5x squared 4 over, and then we have another example. So like, who wants to like try and solve it?
I will. Yeah. Okay, so in the second equation is ax minus 18 to the power of 3 ax dx. So we identify which one is the complex equation, which is ax to the power of x minus 18 to the power of 3. So we identify if the derivative is present, and the derivative of the equation is ax, so it's present. So all we have to do is add 1 to the power and divide it by 1, which is going to be ax minus 18 over 4 to the power of 4 over 4 plus c.
Very good.
And in the second equation,
here,
sine to the power of 3x cosine x dx. So again, we identify which one is the complex, which is sine to the power of 3x. So we identify if the derivative is present. So it is. So all we have to do is find the antiderivative, which is going to be sine x to the power of 4 over 4 plus c.
Great. It means whenever we look at the power, we have to apply the power rule. But before the power rule, we should see if there is a complex function or not. If there is no complex function, we apply the direct rule. If there is a complex function with the inner and the outer function, we apply the U substitution. Good.
Exactly.
Yes. Okay.
Yes,
so the second rule that we have. Oh wait, no. We have this question to solve it.
Okay, so the last question is 1 over 7x minus 9 to the power of 5. So whenever we see that there's a power in the denominator, we lift it up. So it's going to be 7x minus 9 to the power of negative 4. So we realize negative 5, sorry. So we realize if the antiderivative is present and it's not present, and the antiderivative is 7. So all we have to do is write in the outside 1 over 7 instead of 7. So the answer is going to be 1 over 7, 7x minus 9 to the power of negative 4 over negative 4 plus c.
Very nice. Okay. Yes, move.
Thank you.
Okay, so now we're going to talk about the second is logarithmic rule. and the function should be ln and then absolute value of u plus c. So let's see some questions and solve it. Now over here, e to the power of x over e to the power of x minus. So before solving or anything, we should first check if the power of the denominator is 1. And if it's 1, then we're going to apply the logarithmic rule. So the denominator function is e to the power of x minus 3, and the power of this whole function is, so this rule will, like, we're going to apply this rule. So first, we need to find the derivative of the denominator, which is going to be e to the power of x, because the derivative of e to the power of x is e to the power of x, and negative 3 is going to be 0. So at the top, we're going to realize that we have the derivatives, write ln and then the u value, which is e to the power of x minus 3 plus c. So it's going to be like this, without any adding extra numbers, because the derivative is already there. Now we have.
Okay.
Does anyone wants to solve, or like, should I explain?
I want to solve.
Ask any other girl. Okay, who?
Shah?
Yes.
Okay, Farah.
So here
Shah
we're
hai
gonna
do.
just
No, Mrs. Shah.
Okay.
here we're gonna check our numerator and denominator. So we have to see if our numerator is a derivative of our denominator. Here we have 3x squared, which is the derivative of x cubed. So we're gonna go as with our rule, logarithmic rule. So it's gonna be ln x cubed minus 1 plus c.
Super.
Okay, good.
Is there any?
Now, no. Okay. So now let's go to the third rule, which is exponential rule. Okay. Which is going to be e to the power of u plus c. This is the rule of the exponential, like, of how to solve substitution method with the exponential rule. Now, first, before like teaching you how to solve or anything, solve later questions. Now, suppose that an integrand has a term of the form e to the power of f of x. Now, for example, suppose you're trying to evaluate to the power of x. Now, here's one question. Why should you immediately try the substitution u is equal to f of x? Can anyone answer?
I think because it's a complex function.
Yeah, because our rule is e to the power of u, so our u is already here. So we're just gonna take this cube and then solve it. Okay?
Very nice. Okay.
Now let's solve some questions. We have x to the power of x squared plus 3 dx. So first we need to identify our u, which is x squared plus 3. So our u is x squared plus 3. Now we have to find its derivative. The derivative of x squared is 2x, and the derivative of 3 is 0. And we have only the value of x. So what's missing? 2. So we're going to write 2 and write half outside the integral, and then just solve it. Like, yeah, so this is our u. And then first we need to identify the antiderivative, which is 2x. So it's going to be du over dx equals 2x. We're going to move dx to the other side to make du the subject. So after having du, put next to the du because the value of 2 is missing in this equation. And then we're going to put half on the outside of the integral sign, and inside we're going to put 2. So the answer will be half e to the power, and we have the u value here, so we're going to have to replace it with the value, which is x squared plus 3. So it's going to be half e to the power. Do you understand?
Okay, similar, only just, yes, today the connection is very bad. Thank you very much, Ravan. Thanks a lot. Can I share the screen now? Okay, I'm taking again the charge. Girls, the last thing we have to just quickly carry on. So these are the 5 questions, and I want each and every group to explain your questions. Yesterday I gave you these questions to prepare them and in your group discuss everything. So I can see your discussions, and after that I told you that in the today's class you are going to present and explain your group activity to the other classes so that they can have your answers and they can listen to you and you can share your things with each other. So is there anyone, group A, are you ready? Lara, sorry, Zen, are you ready? Group A?
Yes, miss. Yes.
Okay.
Can I share my screen, miss?
Yes, sure. Sure.
Okay. Okay.
After Zen, Ghalia, you are going to present.
Yes, miss.
Can you see the PowerPoint?
It's loading, not yet.
Yes.
Yes.
Okay. Okay, so today this question is talking about how to apply the exponential function integration in real life application questions. So here's the question. Mrs. Styler class collects 50 of bacteria from the locker room. The bacteria grows at a rate of y prime of t is equal to 223.541 e to the power of 1.408 t. Will be there after 6 hours. So in this question, we're going to integrate to find the amount of bacteria that's going to be there after 6 hours. So the first thing we're going to do, in order to solve this question, we need to integrate using the substitution method. So first of all, we identify the inner function. So first of all, we need to identify our inner function, which is u is equal to 1.408t. And then get its derivative, which is du over dt, which is 1.408. And then we get du, so it will be du is equal to 1.408 dt. Then you make the dt the subject to find this. So dt is equal to du over 1.408. After that, we should integrate the function they gave us in the question, which is this function here. We should integrate it to start solving. First of all, we took this constant outside the integral sign. And then we should leave, we want this du alone, okay? So we divide this number with 1.408 and replace u with 1.408 because we identified u as 1.408t. So we replace this one with u and dt, this dt with du over du over 1.408 because we identified dt earlier that it is du over 1.408.
Okay.
So after that, okay, 1 second. Yeah. So after dividing this number by 1.408, we get this. So now we integrate e to the power of u. You know that the antiderivative of e to the power of u is e to the power of u plus c. So after integrating, this is the function that we're going to get. Okay, so it's given in the question that y of t is equal to 50 and when t is equal to 0. When t is equal to 0. So we replace y of t with 50 and t with 0 in the antiderivative to get the c value. So after we replace, we keep c the subject in order to value, and then after calculating, we're going to get c as this value. Yeah, and then we replace the c function, the c value in the function we have already. Okay, so go back to the question. The question asks us to find the number of bacteria after 6 hours. So T will be equal to 6. So we have this function. We replace T with 6 and calculate y of T to find the number of bacteria. So after calculating the amount, after calculating this, okay, after replacing T with 6, you get y of T as 740,646 bacteria. Like approximately, they're going to be 740,646 bacteria after 6 hours. And
okay, very nice. Very nice. Ghali, are you ready for sharing your screen, group B?
Yes, miss, just a second.
Okay, Ghali. Nice, Zan. Nice work. Thank you so much for explaining us, and I hope that others also understood.
Yeah.
So let's see what Ghali come up with.
Can you just share the screen because I cannot.
One second, Ghalia. Okay, let me check, Ghalia. You sent me on WhatsApp, but let me check, Ghalia. 1 second, Ghalia. Okay, Farah, until Ghalia's I'm finding, or she's giving it to me, and okay, Ghalia, I found it. Wait.
Okay.
Okay, I found Ghalia. 1 second. Okay, can you see the screen, guys?
Yes.
yes, miss, we can see.
Okay, so Ghalia, yes, Ghalia, start, and we will be so quicker, okay? Yes, Ghalia.
Okay. So we will now we're having a question which is a real life application. We will use the exponential functions of integration. So the question says, suppose the value of a yacht in dollars after t years of use is v of t equal to 275,000 e raised to negative 1.7 t. What is the average value of the yacht over its 10 years of use? So here we want to find the average value of a function. So actually, how we can find the average value, which is y equal to f of x, over a specific interval, which is a and b. So to find it, one must integrate the function by using the fundamental theorem of calculus, as we know, and divide the answer by the length of the interval, which is given in the question. So we are having this rule of average value, which is f of c equal to 1 over b negative a, b and a f of x dx. Okay, so the first step is how we're going to use the upper limit and lower limit of an integrand in a real life application. So we will have here v of 0 equal to 275,000 e raised to 0. So that we can find the a, and then we will replace b by the 10 years in the question. We will use the substitution method. Okay, so we put the e raised to 0 equal to $275,000. So now we're having the a, which is the 0. So now only we are going to replace 1 over 10 negative 0. The 10 is the 10 years, and the 0, which we get it from the substitution method, which is v of 0. 10 upper limit, 0 lower limit, 275,000 e raised to negative 1.7 dt. Okay. Now the second method, we're going to the u method. The u here is our negative 1.7. du is negative 1 for negative 1.7 dt. So now we want to make the dt the subject. So it is equal to du divided by negative 1.7. Okay, now our third step is 1 upon 10 integrand 10 and 0. 275,000 e to the power of u. du divided by 1.7 because we just took the dt as a subject earlier. Okay. On the fourth method, 1 upon 10, 10 and 0 negative. We are going to use our calculator to find the value of this 275,000 e to the power of. Yes, we're going to divide it. So we're going to get negative 1.61764.059 e to e raised to u du. Okay, now we're going to integrate it. How? We're going to use the value in our bracket here, and then we're going to put it raised to our previous number, which is negative 1.7t, and put the upper limit and lower limit outside the bracket. Okay. Now, as well as we have the 10 and the 0, so we're going to replace it after we just do the step, which is the sixth one. So 1 over 10, the value we get, which is negative 161,764.7.059 e to the raised to negative 1.7t, and 10 and 0. We are having here upper limit and lower limit. So we're going back to the question. What they want from us? We want what is the average value of the yacht over its 10 years. So we are going to write the value, which is negative 1.61 next row, and then raise to negative 1.7, and replace the
upper value minus lower value.
Yeah, upper value, which is 10, and then plus and negative and negative, which is plus, and then one
same thing then.
Yeah, the same thing by the 0, and then we're going to get the value. The value is the answer, $132,212.96. So this is our average value of a yacht. Yes.
Thank you so much. Thank you. We are running with the time. Now, Farah, are you going, or Alia, you are going to explain me maybe two?
I think Alia's first because I'm good D.
Okay. Alia, are you ready? Yeah. Okay, let Lara first and then Alia, okay? But we have to be faster. Only Alia and Lara, we will have the time maybe. Yeah.
Should I share this?
Okay, share. Okay.
Today we're gonna do a exponential function and real life application. The question says the population of the town grows at the rate of R equals 300 E 0.3 T.
Lara, we can see your second slide.
1 second, miss. The people per year, where T is the time in years, at the time T equals 2. The town's population is 1,200 people. What is the town's population at 7? So basically here we have a rate of growth in a town, and at the current initial time, which is 2, our town population is 1,200. So here they're asking us to find the town's population when T equals to 7. So this is the growth rate. So this is the growth rate that we have.
Lara, we can't see. Only we can see your title page.
We're still in the first slide.
Now.
Not yet. Wait. Yes, now.
Yes, we can see now.
Now we can see. Yes.
1 second, miss, 1 second.
Mm-hmm.
What about now?
Yes.
Okay, so now as we know that we have the town's population rate, which is P 1,200, which is 300 multiplied by e raised to 0.3 T per year. So now we're gonna solve it for T equals 7. So they gave us the expression which will guide us in solving the integration, which is 1,200
plus the integration from 2 to 7 with our RT, which is our rate, our growth rate. So let's start by replacing our RT with the growth rate, which is 300 multiplied by e raised to 0.3 t. Then, by shifting the number 300 with 1,200. One second. Okay. By shifting the 300, and then by applying the integration rule, we should find the derivative of antiderivative of e raised to 0.3, which is e 0.3 t 0.3 t prime.
Okay.
By giving us 0.3 e raised to 0.3 t. So this would lead us to this. And we're missing the derivative, which is 0.3. The number 0.3 is missing. So we're going to add it before the integration and outside the integration sign. To do so, we're going to put 1 over 0.3 before the integration sign. And then by having the antiderivative of, the derivative of e, we can begin solving by integrating it. So the integration from 2 to 7. So we're going to replace the 2. We're going to replace the 2 in the place of t, and we're going to replace the 7 in the place of t, which will give you this. And obviously don't forget 1,200. Good. And then we're gonna have calculating this will lead you to 100. What's this, miss?
Make it keep. Keep. So in the end, what Lara, it's okay because today, you know, the technical issues also. So in the end, Yani, you have to apply the limits, upper limit minus lower limits. Whatever she said that you have to calculate the population after the 7 years. So in order to calculate that thing, you have to apply first the upper limit, that is 7, and then the lower limit, that is 2. So Alia, now you have only 5 minutes to explain your question.
So we're going to get this number in the population at 7.
Miss, I'm group D.
Okay, so Farah, you want to explain? Okay,
yeah,
carry
no problem. I sent you the PowerPoint in WhatsApp.
Farah, okay. This guy. 1 second, Farah. Okay, Alia, you will share your PowerPoint, or I have to share?
Yes, I have to share.
You will share or I will share? 1 minute. You or me? You? Okay, yeah. You carry on until I will find out for us. You carry on then. Okay, okay, carry on yours, and I found Sarah's.
Miss, I can't share my desktop. I don't know why. Can I send you? I don't know. I tried.
Okay, let me share with start with the Farah. Okay, and then okay. Farah, can you see these things?
1 minute. Not yet. Yes. Maybe before PowerPoint. Yeah.
Okay, Farah, carry on. Okay, let's listen to Farah. We have 10 minutes. Okay.
Okay, so the model for this temperature T in degrees Fahrenheit of the glass of lemonade T hours after being placed in a room with a constant temperature of 70. Given an initial temperature of lemonade was 40, is T equals 70 minus 30 e to the power 5T, negative 5T, determine the average temperature over the last 5 hours. So they mentioned the word average. So we use the average mean value theorem because they mentioned the word average in the question. Okay? So the average mean value theorem. So our first step will be 1 over b minus a, and then integrate b to a. So
A to B.
our A to B. So our limits here is from 5 to 0, 0 to 5. So it will be b to a. So it will be 5 minus 0. And then we write the question integrated. Now we find our u, which if we use the exponential function, it will be negative 0.5t, because e is to the power of this number. So this is our u. Okay. Our du is negative 0.5 dt. So if we want to find dt, we will bring the negative 0.5 to the other side. So dt will equal to du over negative 0.5.
Okay.
Okay, our next step is to replace dt by this function,
du.
which is, by du, and put an integral sign in front of each one, which is the sum and difference rule. Okay, so next step, we will solve it. So 30 divided by negative 0.5 is negative 60.
Okay.
And then we integrate using the fundamental theorem part 1. So from 0 to 5, so we replace it one time with 5 and one time with 0 and put it in the calculator to get the final answer.
Okay, so it means here you are, for the 70 dt, she is applying the direct method, and for the e to the power something, she is using the substitution method together along with the exponential function. And you know how to integrate. You can use the u method or you can just do it directly. Okay, so very nice, very nice. Alia, now you, huh?
Yes, it's okay.
Okay, so you want me to share on your behalf also? Yes, we can see. We can see your. Yes, we can see now.
Okay, so my question talks about the population of a town grows at a rate of e to the power of 1.2t minus 2t people per year. At t equals 2, the population is 1,500. They want us to find the growth between t equals 2 till 5 and the town's population at t equals 5. So first of all, we will integrate from 2 to 5, write the equation, and then take it's a complex function where e is to the power of 1.2. The inner function is 1.2. We take the derivative of the inner function, which is 1.2. It's not there, so we write it in and outside.
Go write it and show us the other slide. Move to the other slide.
I moved this. You can't see it now?
We can see only the question.
We can see the second slide.
Yes, now, okay.
Okay, so we write the derivative in and outside, and then take the antiderivative of 2t. So it will be 2t squared over 2. And then replace 5 and 2, minus them, and get the final answer, 306 people approximately. And then for the total population, we add 1,500 plus 306, which is 1,806 people.
Very nice. Thank you very much, guys, for everyone who shared this screen. Now, the last thing which I want, if you have any kind of the question, please feel free to tell me and ask the question. Do you have any other question? Do you have, girls, any question regarding any integration?
No.
Thank you so much for the cooperation. Thank you so much for the cooperation. Okay, bye-bye. See you.
Bye.
Thank you.
Thank you, Miss.
We will miss you.